Hey guys, welcome to this video of time complexities. In this video, we're going to see that what are the major time complexities and algorithms we should keep in mind while doing competitive programming questions. Okay, you might have seen that in CodeShift, there are many subtasks divided like subtask 1, 2, 3, and the basis of subtasks, each subtask has some constraints on the basis of n. Okay, so we have to keep in mind that we have to clear all subtasks and do it in an optimal way so that all subtasks can be cleared. Okay, otherwise we get a TLE. You all know that. Okay, so let us have a look on that. See, if our see in any processor, there are max 10 to the power 8 operations to be performed in 1 second. Okay, so there are 10 to the power 8 computations which are done in 1 second. So our time complexity should not exceed that. Okay, if our time complexity exceeds 10 to the power 8, then we obviously get TLE, that is time limit exceedation जो भी है, ठीक है, and and to do it and to avoid TLE, we have to do the solution in an optimal way. And so how can we do in an optimal way? So watch this video till the end. Okay, so if we are given n as 10 to the power 18, okay, so we have to make it 10 to the power 8. Okay, because 10 to the power 8 computation नहीं हो सकती, 18 नहीं हो सकती, so we have to make it low. So if we do our solution in of log n, okay, log n is basically 18 log 10 to the power 18 is basically 18 log 10. Okay, 18 यहाँ पे आ जाएगा and यहाँ पे आ जाएगा. Okay, if we do it in 18 log 10 time, then it is obviously lesser than 10 to the power 8. So if we are given our constraint as 10 to the power 18, then we have to use of log n. This is the only way of doing this. Okay, and we can do this of log n in many ways. One of the ways binary search algorithm. Okay, there are many algorithms, but we can use binary search. This is the most commonly used algorithm in this time complexities. Okay, and now if we are given time complexity 10 to the power 8, so we can do this by only one for loop or using using DPs. Okay, using a 1D DP, one dimensional DP to stay in this constraint. Okay, if we are given 10 to the power 4 as the value of n, maximum value of n is 10 to the power 4. Okay, so we can do this of n square. Okay, so n is 10 to the power 4 and n square is basically 10 to the power 8, right? And our maximum time is taken 10 to the power 8, so we can do it in 10 of n square, right? Moving forward, if we are given time complexity as 10 to the power 7, so how can we do this? We can do this by simply using one loop, or we can use any sorting algorithm, right? Sorting algorithm mostly takes n log n time. Okay, so 10 to the power 7 में अगर n log n में 10 to the power 7 डालेंगे तो क्या होगा? 10 to the power 7 into log of 10 to the power 7. Basically 10 to the power 7 into 7 log 10, and it is less than 10 to the power 8. Okay, so this works, and we do sorting. We doesn't write complete sorting algorithm in Go. Rather, we write simply a HTL function of sorting like this. Sort. If you're given array, then array plus its size, or if you're given a vector, then v dot begin to v dot end. Okay, and if you want to do a custom like this, custom sorting. Okay, so moving further, if we are given a the value of n as constrained as 10 to the power 2, then we can make up to n cube. Okay, This can't be done with n to the power 4, as there are some major issues in doing 10 to the power 4 operation. If you are given value as 100, okay, you will surely get TLE there. Okay, and because this also space-time complexity is taken in the consideration, and it gives TLE there. Okay, if we are given constraint as n is between 0 to 90, then we can use n to the power 4 as our time complexity, and we can use four for loops here, right? If we are given n as 0 to 20 के बीच में दिया है, then we can take 2 to the power n. ये क्या हो गया? Okay, 2 to the power n is basically, इसमें recursion use हो सकता है, like f of n is equal to f of n minus 1 plus f of n minus 2. This will give a 2 to the power n is basically, we got this by, so if we are given this recursive function as f of n is equal to f of n minus 1 plus f of n minus 2. Okay, so in this recursive n minus 2, so okay, so in this recursive function we will surely end up making a recursive tree, basically like let's hold like this. F of n is there. Okay, so it is calling f of n minus 1 and f of n minus 2. Okay, and it is calling f n minus 2 and n minus 3. Okay, it is calling n minus 3 and n minus 4. Okay, and this is a non-ending cycle if we doesn't use a base case. Okay, this is a very long cycle. Okay, so, and the total number of calls here is 2 to the power n. So the time complexity taken here is 2 to the power n. Okay, so if suppose we are given n as 10 to the power 4, and we have to use this algorithm, we can do that function, that program by this algorithm, but our time complexity doesn't permit us that. Okay, so we have to do that question in an optimal way. Okay, so this is basically this function is of basically finding factorial of a number. So factorial Fibonacci of a number n. Okay, so if we are given, suppose 10,000, n is equal to 10,000, and we have to calculate Fibonacci of 10,000 numbers. Okay, so how can we do that? We can't use this algorithm there, because this will surely give TLE there. Okay, so we have to do that in an optimal way, and we can do that in dynamic programming, right? You can see here as there are many repetitions that, let me change the color. See, n minus 3 is repeating, n minus 3 is repeating, n minus 2 is here, n minus 2 is here. Okay, and there are many repetitions downways. Okay, so to avoid this repetitive calls, we use dynamic programming, as we store the number once it has been appeared, and we reuse it if it is required in further calls. Okay, so by that we can do this program in O of n time, rather doing it of to the power n. Okay, so that's all for this. Let's see further. If we are given n as 0 to n between 0 to 11, then we will use O of n factorial. We will not use this, but this is the maximum time complexity we can use. Okay, if we are given 10 to the power 6, then we can use O of n log n, and we can also use O of n log of log n. This is basically a prime sieve. You might have heard that there is an algorithm called, let me write this. There is an algorithm by which we find number of primes in a particular given range. Okay, and we do this by this algorithm sieve of analysis जो भी है. Okay, and there we get a time complexity of n log of log n. Okay, this is not everywhere used, but this can be used here, and as this is a very common algorithm and common way to do that. Okay, so this is much for time complexities. You have to keep in mind all of these, and you have to use optimal algorithm which you made customize, या जो भी तुम कस्टमाइज algorithm बनाते हो तुम्हें कुछ ऐसी algorithm बनानी पड़ेगी जो इस टाइम कॉम्प्लेक्सिटी में वर्क करे. ठीक है, अब अगर तुम्हें दे दिया कि 10 की पावर 4 है एंड तुमने algorithm बना ली जिसमें 3 लूप हैं, ऑब्वियसली नहीं चलेगा ना, राइट. सो तुम्हें देखना पड़ेगा कि तुम जो भी algorithm बना रहे हो उसकी टाइम कॉम्प्लेक्सिटी निकाल के देखो कि अगर 10 की पावर 8 से कम आ रहा है then that algorithm can work, otherwise you will get TLE in any of the subtask. Okay, so thank you for watching this video and I hope that मिलते रहोगे सब अगली वीडियो में. Okay, bye.